If you picked up a sheet of plywood from a lumberyard in 1985, you'd feel real wood. Thin layers of actual timber, cross-laminated and glued together. A material that builders had trusted for the better part of a century. Now walk into any new home built in the last 20 years. Pull off a piece of siding. Behind it, you'll find something that looks completely different. A panel made of compressed wood chips, strands, and glue, pressed flat into a sheet. It's called Oriented Strand Board, or OSB. And if you've bought a home built since the year 2000, there's roughly an 80% chance that this is what's holding your walls together. Most homeowners have no idea. They assume there's plywood behind their siding, because that's what their parents had. That's what they've seen in every home renovation show. But the construction industry quietly made a swap decades ago, and the reasons had nothing to do with building you a better house. So how did a material invented in a California lab in 1963 end up inside nearly every new wall, floor, and roof in North America? It comes down to one thing: money. OSB hit the commercial market in the 1970s, and for the first couple of decades, builders didn't trust it. The early stuff splintered when you unloaded it off the truck. It looked cheap because, well, it was cheap. Homeowners didn't want it in their walls, and builders who used it got accused of cutting corners. But then, something changed. During the 1980s, apartment builders and multifamily developers started adopting OSB quietly. No homeowner was standing on site watching the framing go up on a 200-unit condo complex. And the math was hard to ignore. The National Association of Certified Home Inspectors estimates that OSB saves about $700 over plywood on a standard 2,400 square foot home. On a single house, that's a rounding error. On a development of 200 homes, that's $140,000 in savings. Production exploded. In 1990, OSB output sat at 7.6 billion square feet in North America. By 2005, it had more than tripled to 25 billion square feet. The number of OSB mills jumped more than 50% in just 7 years during the 1990s. By the year 2000, OSB had reached market share parity with plywood. Today, depending on which industry report you read, OSB commands somewhere between 75 and 80% of the structural panel market for new home construction. Real plywood, the kind made from actual wood veneers, has been pushed to the margins. You'll still find it in high-end cabinetry, finished carpentry, and a handful of hurricane-prone counties in Florida where building codes require it. Everywhere else, OSB won. Not because it was better, because it was cheaper. Now here's where it gets interesting. OSB works fine under one condition. It has to stay dry. And that's a problem, because construction sites are not dry places. When a house is being framed, the walls stand open to the weather for days or sometimes weeks before the roof goes on, and the building gets sealed up. Rain falls on the sheathing. Snow sits on the subfloor. Morning dew collects on every exposed surface. For plywood, this is usually manageable. It absorbs some moisture, swells a little, and when it dries out, it generally returns close to its original shape. OSB does not do this. When OSB absorbs water, the compressed wood strands swell, particularly along the edges where cuts were made during installation. Research published in the journal Wood Materials Science and Engineering found that even brief water submersion caused irreversible thickness swelling in OSB panels ranging from 13 to 18%. That swelling doesn't go back down. Once those strands puff up, they stay puffed. The board gets thicker, weaker, and softer. And it gets worse. The same properties that make OSB resist initial moisture penetration, the wax coatings and resin binders, also make it incredibly slow to dry once water does get in. Building scientist Joseph L. Stiburek has written extensively about this. Plywood can move water vapor through at a reasonable rate, allowing walls to breathe and dry. OSB acts more like a moisture trap. Water gets in, but it struggles to get back out. And trapped moisture in a dark wall cavity is exactly how you get mold, rot, and structural failure. In rainy climates like the Pacific Northwest, roofing contractors report finding entire attic sections of OSB covered in mold and rotting. All it takes is one small leak that goes undetected for a few years, and the damage spreads across entire sheets because OSB wicks moisture laterally through its strands. A plywood roof deck with the same leak might show a small stain. OSB can turn to something with the consistency of wet cardboard. The real trap for homeowners is that you can't see any of this. The OSB is behind your siding, under your shingles, beneath your flooring. By the time the damage becomes visible, you're looking at a major repair. Contractors who do re-siding work talk about pulling off clapboards on 10-year-old homes and finding saturated, crumbling OSB underneath. The culprit is almost always poor installation. Flashing that wasn't detailed correctly around windows. House wrap that was stapled up but never properly taped at the seams. Siding installed directly against the sheathing with no air gap to let moisture escape. That last one is the big one. Building scientists have been saying for years that homes sheathed with OSB need a vented rain screen, which is basically a small air gap between the siding and the sheathing that allows any moisture to drain and dry. It's not expensive, it's not complicated, but the vast majority of production builders skip it because it adds time and a small amount of material cost. And most building codes don't require it. So what can you actually do about this? If you're buying a new construction home, the most important thing you can do is show up during framing. Look at the sheathing before it gets covered up. Ask your builder whether they're installing a rain screen behind the siding. Ask how they're detailing the house wrap around windows and penetrations. These are the details that determine whether your OSB walls last 30 years or start rotting in 8. If you're renovating and you're pulling siding or opening up walls, check the condition of the sheathing behind it. Look for soft spots, dark staining, and edges that have swollen or started to separate. If you find damage, cut it out and replace it. Don't just cover it back up. For subfloors specifically, consider spending the extra money on a moisture-resistant engineered panel like Advantech or LP Legacy, which use advanced resins designed to resist edge swell. These cost more than standard OSB, but they're designed for the real-world conditions of a construction site where rain is inevitable. And if you're building from scratch and you have the budget, there's nothing stopping you from specifying plywood sheathing in your plans. Yes, it costs more, but plywood dries faster, holds nails better over time, and doesn't irreversibly swell when it gets wet. For a material that's supposed to hold your house together for the next 50 years, that $700 savings starts to look a lot less impressive. The construction industry made a choice a few decades ago. They chose the cheapest option that met minimum code requirements, and they made it the default. That doesn't mean it has to be your default. If this kind of thing matters to you, hit subscribe. We dig into the building materials and construction shortcuts that nobody talks about every single week.